Hello and welcome to the EnvirotechOnline podcast. As always, I'm Jed Thomas, editor of EnvirotechOnline, here to guide you through what's emerging, overlooked and misunderstood in environmental monitoring.
And I'm Alan Booth, senior editor here at ILM Media, and today we're venturing into one of England's most misunderstood landscapes and one of its most ambitious data projects.
That's right. Today we're talking about the England Peat map, which was launched in May of this year by Natural England. On paper, it's a landmark achievement, a national AI-powered dataset mapping the extent, depth, vegetation cover and condition of peat and peaty soils across the country. It was designed to support everything from climate action and restoration funding to wildfire planning and land use regulation.
Sounds like a win for soil and carbon monitoring, right?
Well, it should have been, but in practice, it's become something else entirely. A case study in how algorithmic tools can fall flat without ground truthing. Because despite its technical sophistication, the England peat map is under fire from the very people it was supposed to help, farmers and conservationists, some of whom have said that their data simply doesn't hold up on the ground.
Why? What's gone wrong?
Well, in short, it's misidentifying peat, in some cases quite dramatically. Dartmoor farmer Kat Frampton has emerged as one of the map's most outspoken critics, and she's pointed out that limestone pavements, granite tors, even reservoirs and rivers are being flagged as deep peat. Meanwhile, actual known peatlands, including some designated sites of special scientific interest, are missing altogether from the map.
So not just a few glitches, but large-scale misclassifications.
Exactly, and the errors aren't random. They cluster around technically complex areas like rock outcrops and artificial reservoirs, places where a machine learning model might struggle to accurately predict. But it goes deeper than that. Even Natural England admits that the map shouldn't be used to determine peat depth, which is a pretty staggering disclaimer for a product that's supposed to support the restoration of our degraded peat stores.
What data was the map based on?
So it was a combination of remote sensing conducted via satellites using LiDAR technology, plus historical soil records and a handful of new field surveys. All of that, which is around 300,000 data points, was then used to train a machine learning model to predict where the peat should be on a map. The result was a national data set with claimed accuracies of 95% for peat extent and 94% for vegetation cover. But that 5%, 6% error rate has resulted in a few non-trivial errors, and these errors are not evenly distributed across the terrain.
Let me guess, it's hitting the most ecologically sensitive or contested terrain.
You are bang on. And this map is already being used to inform funding decisions, conservation priorities, even regulations on activities like controlled burning. But if it misidentifies what's peat and what's not, obviously we risk targeting the wrong areas and ignoring the right ones.
So what does this mean for our listeners?
Well, for most, it's just a cautionary tale really about algorithmic models. But if you're working with soil moisture probes, gas flux chambers, organic content analyzers, that sort of thing, it's really a sign not to treat national data sets about soil as gospel. They are definitely a starting point, but they're not a substitute for site-level data. Ground truthing will always remain essential.
But to be fair, the map does offer something new, doesn't it?
Absolutely it does, yeah. For all of its flaws, the England peat map is the most comprehensive national peat dataset we've ever had. It provides downloadable GIS layers showing peat depth, vegetation type, drainage features, erosion risks, even bare peat exposure, which is a useful proxy for how likely an area is to emit greenhouse gases. And for large-scale modelling and long-term trend analysis, this national dataset and just the scale of it really is invaluable.
And I assume the map feeds into climate and carbon targets?
Absolutely, that's part of the whole point for starting this project. Peatlands are England's largest terrestrial carbon store, and this is data from the map now, 80% of our peat is degraded, which means it's not sequestering carbon as well as it could. The map shows that only 1% of areas contain active sphagnum moss, which is what actually builds peat. So we've learned a lot from this data set, and we've learned that our peat is in a terrible state.
Especially in the lowlands, right, where drain peat is a major GHG source.
Exactly, and it's some of the hardest terrain to map accurately, because centuries of farming and drainage have altered the landscape considerably. The peat map makes a real effort in these zones, but we still need instruments to go out into the field, things like conductivity probes and soil nutrient meters, to accurately track what's actually happening.
So what's the long-term value of this tool if we use it correctly?
Well, it could become a sort of foundation, a strategic framework, a way to prioritise restoration, assess carbon stocks, guide monitoring efforts, and link land use to hydrology and emissions, but only if we acknowledge its limits. AI can't replace local expertise or in situ validation.
What would you say, therefore, is the biggest takeaway?
Well, I said there's about three things. The first, like I said, is that models, algorithmic tools, always need to be ground truth. The second is that tools like this need to be transparent and correctable by the people who actually use them. And the third thing is that professionals in this field need to advocate for data integrity just across the board, or they risk having their work undermined by flawed algorithmic tools.
So it's an opportunity to rethink how we build trustworthy and actionable environmental data.
Yeah, that's exactly right. And at a time when the restoration of ecosystems is becoming more and more of a priority for communities around the world, we really need reliable baselines to do that work. And that starts with the frontline monitoring practices. So the England peat map is definitely a pioneering and reasonably successful attempt at a massively important project, but there's just still a lot of work that needs to be done.
It certainly sounds like that. But if you're a soil monitoring professional and want to explore the peat map for yourself, you can find it via Natural England's Open Data Geoportal or the DEFRA Data Services platform. It's open access and the technical guide is worth a read.
And if you want to keep up with how the story evolves, from technical updates to field validation studies, head over to www.envirotech-online.com. We've got in-depth interviews, webinars and analysis to help you stay ahead of this developing story, and it's completely 100% free to become a member.
And don't forget to subscribe to this podcast so that you don't miss what's next. We'll be back soon with more insight into the monitoring tools and policies that matter.
Thanks for listening, everyone. Until next time.
Cheers, Jed. Goodbye from me.